What's up, guys? I'm extremely sorry the previous video had to be stopped in between due to some emergency. But yeah, so we'll take it from the point where I left. Okay, so we were trying to find out uh, the range, the total time of flight, the final velocity, and the angle at which the ball will hit the ground. So I was telling you that the vertical motion is independent of the horizontal motion, and I also I tried to uh, write the various quantities for vertical motion and the horizontal motion. So in the vertical motion, the initial velocity is 0, the acceleration is minus g, initial coordinates, final coordinates. Similarly for the horizontal motion. Now let us try to uh, solve the equation. Okay, so again let me draw the diagram. This is the height h, this is how the ball has been thrown, this is the trajectory. Okay, this is how the ball is hitting, the angle, final velocity, initial velocity, and this is the range. Let us talk about the vertical motion. For vertical motion, let me write the equation of kinematics. So we know SF minus SI is equal to UT plus half AT square. I am writing for vertical motion. Okay, so for vertical motion this equation will become SFY minus SIY is equal to UYT plus half AYT square. Now what is the final coordinate just before hitting? The final vertical coordinate is 0 because it is coming to the ground, so vertical displacement is 0. The initial coordinate is h, to 0 minus h, the initial vertical velocity is 0 plus half acceleration is minus g into t square. So from here I get t is equal to 2h by g under root. So this is the total time of flight. Okay, this is the total time of flight. Now this time is valid for horizontal as well as the vertical direction. So now if I ask you what is the range, so range will be ut plus half at square. Again I am using this equation for horizontal motion. Okay, I can write like this also, SF minus SI is equal to ut plus half at square. So for horizontal motion or x coordinate, this will become SFX minus SIX is equal to UXT plus half AX into t square. So the final coordinate is r, initial coordinate is 0, initial velocity is ut, acceleration is 0 in the x direction. So r is equal to u into t, where t is the total time. So range will be u into under root 2h by g. This is the range. If I ask you what is the final velocity, so if you see the vertical motion as the ball is coming down like this, I can draw the vertical motion like this. Okay, and this is the horizontal motion. So what will be the final vertical velocity? So let me use v is equal to u plus at, and for vertical this will become vy is equal to uy plus ay into t. So final vertical velocity is, initial vertical velocity is 0, acceleration is minus g, and what is the total time? Total time is under root 2h by g. So this will become minus under root 2gh. This is the final vertical component. Now, what is the meaning of this minus? This minus simply means that the ball is in the downward direction. The velocity is in the downward direction because I've taken the upward direction as positive and the downward direction as negative. Okay. And what is the final horizontal velocity? That will be the initial horizontal velocity because there is no acceleration. So this is u. So combining both these, what is the final velocity? That will be under root of horizontal velocity square plus vertical velocity square. So under root u square plus 2gh. So the final velocity is under root of u square plus 2gh. Okay, the total time is under root 2h by g, and the range is u into under root 2h by g. Okay, so we have calculated three quantities. If I ask you what is the angle of hitting just before hitting, so if you see, this is the ground, and suppose this is how the ball is coming. So this is theta, this is theta. So this is, if I complete the triangle here, this is the final velocity, total velocity. This is the horizontal component of velocity, and this is the vertical component of velocity. Okay, very clearly. So I can write in this triangle, in triangle ABC, tan theta will be equal to Vy upon Vx. So theta is tan inverse of Vy upon Vx, okay, which is nothing but tan inverse of the vertical component is, I guess, under root 2gh, okay, divided by what is the horizontal component, u. Okay, I'm taking the absolute value because I'm already considering this theta to be positive. I'm not calculating it from here. If I have been calculated this angle from here, alpha, then I have to write tan inverse minus 2gh, the actual velocity that you are getting. But since I'm just taking the magnitude, so this will do. So this is the theta considering this triangle. Okay, so I have told you the range, the final velocity, the angle at which it hits, the time period. Okay, so okay, that's it. In the next lecture, I'll be telling you projectile motion on an inclined plane. Okay, so in the next lecture, just to give you a brief, just a glimpse. So this is suppose theta, and you're throwing a ball like this. Okay, you're throwing at an angle of alpha and with a velocity of u, and the ball is hitting like this. So from the horizontal, the angle is beta and final velocity. So we'll calculate t, v, beta, and obviously this range r in the next lecture. Okay, so stay tuned and we'll meet in the next lecture. Bye bye, take care.